Hello friends. In this session, we are going to talk about something that we've seen throughout the course of our life. Something which we see a lot and of which we understand only little about. It is what separates the day from the night. It's what you want to see when you're in your darkest hour and hope things are going to be alright. It comes in many colors, but collectively it's white. When it comes to speed, nothing can be compared to the power of its flight. Believe it or not, it's also responsible for the joy of sight. What is it? It's light. Whether it's the enjoyment of looking at ourselves in the mirror, or the beauty of nature, or this colorful world we live in, at the very base of our good fortune is the phenomenon of light. For centuries, across many cultures, the sun has been considered as the giver of life on earth and has been worshipped as a source and symbol of light. So what is the relation between light and life? Well, that's easy. In our biology videos, we have seen how sunlight is responsible for production of food in plants, maintaining the balance of the water cycle, and for general health. But understanding what light is and what it does is a bit more challenging. For that, we'll have to look beyond what we see. Don't worry, we'll cover that gradually in this session. Depending on where it originates from, the sun, the moon, lightning, certain types of glowing insects, worms, and fishes are all examples of natural sources of light. While a candle flame, various types of torches, lamps, and light fixtures are amongst the artificial light sources. Now let's understand this. Our sun emits light, really strong, intense light or radiation called electromagnetic radiation or EMR. The radiation is called electromagnetic because it contains both electric and magnetic properties. Electromagnetic radiation is a large family consisting of 7 members known as the electromagnetic spectrum. One particular family member which lies in the middle of the spectrum falls on Earth and which our eyes detect is called visible light or the visible spectrum. It's so small that if we consider the entire electromagnetic spectrum to be around, say, 2,500 miles, the visible fraction would be just 1 inch. It is within this inch that we live in our world of natural and extraordinarily high definition color. We enjoy this privilege of color due to the presence of certain specialized cells in our eyes called rods and cones, which we've come across in our previous video. Now, the other types of electromagnetic radiations are also called light, but not visible light. So automatically, they are considered by us to be invisible. So now we know the light which we have naturally been introduced to since birth and which we see throughout our life is actually radiation, and radiation of a good type. That's an important source of energy for life on Earth, as we've seen earlier. Now, just as members of a family differ from one another and have their own unique identity, so also these fractions of radiation, although part of the same family of light, are slightly different from one another. This difference is due to 3 factors that are interdependent and give each member its individuality. These factors are wavelength, frequency, and energy. Let's look into what these are. Imagine the light that we know to be represented in the form of waves in an ocean, like this. What differentiates a wave from calm waters is the presence of an area of elevation and an area of depression. In terms of our representation, the elevated area is called a crest, while the depression is called a trough. Wavelength is nothing but the distance between 2 successive crests or 2 successive troughs. The smaller the distance between the crests or troughs, the shorter the wavelength, and vice versa. Now let's consider the case of a rough sea and a relatively calm sea. When we look at any part of the water for, say, 1 minute, we notice for that 1 minute where we look, the rough sea has more number of waves passing us by, which are shortly spaced from each other, while the calmer sea has fewer waves, which are far apart. So, the number of waves passing us in the area we observe for the time of 1 minute is referred to as the frequency of waves. Thus, for the rough sea, the frequency of waves is greater as compared to the calm sea. We just mentioned that for the rough sea, the waves are closer to one another. Closeness means shorter space between waves, which in turn means shorter wavelength. The third factor is also easy. If you've stood near the sea when it's wavy, you would have noticed the surrounding to be windy. Thus, for more number of waves to be formed, the wind energy or just plain energy associated is greater for the rough sea than that for the calm sea. So now we'll update our observation. Let's join the dots. As the wavelength shortens, the frequency increases and the energy increases too, and vice versa. These three factors are different for each member of the electromagnetic spectrum. Now, just because we cannot see the other types of radiations there are, doesn't mean that they aren't there or that they're not useful. Let's go back to the electromagnetic spectrum. We have radiations of the longest wavelength and thus the lowest frequency and energy. These radiations are called radio waves. They are used for broadcasting TV and radio signals because they can cover a greater distance through the atmosphere due to their large wavelength. As we move towards the right of the spectrum, the wavelengths keep getting shorter and the frequency and energy keep on increasing. Next to radio waves, we have microwaves, used in appliances like the microwave. They are also used in channels of telecommunication like mobile networks, Bluetooth, and wireless LAN protocols. Next, we move to infrared. This region of the spectrum is more known for the aspect of heat associated with it, as they have higher energy as compared to radio waves and microwaves. They are used by appliances like grills and electric stoves for heating and cooking food. IR is also used as a part of heat therapy to relieve aches and pains. Did you know that reptiles like the snake view their surrounding through infrared radiations, just like how we humans do the same through visible light? We have earlier seen how visible light makes the world visible to us and adds color to our life. So this part of the spectrum is associated with various types of light fixtures, the ones we enjoy and the ones that are really important. Apart from us humans, animals like dogs, cats, mice, monkeys, etc. also see in the visible spectrum, though their sight is not as good as ours. The part of the electromagnetic spectrum from radio waves to visible light have comparatively lower energy, so these radiations are referred to as low energy radiations, which are safe even after prolonged use. Moving further, we have ultraviolet radiations. The uses of ultraviolet radiations are also widespread in various aspects of life. They are used as sterilizing agents by the medical industry and by water purifiers to get rid of harmful bacteria. It is also used by dentists to harden teeth fillings and by banks to detect fake currency notes by observing certain symbols or patterns on the notes that are only visible under ultraviolet light. Another amazing fact is that certain organisms, like insects, form an image of their entire surrounding using only ultraviolet radiation. X-rays, as we are aware, are also used to a great extent by the medical industry to examine the state of bones or foreign objects in the body. It is also used by airport security to scan luggage for potentially dangerous objects. Gamma rays are a type of radiation with the lowest wavelength and the highest energy. They are the exact opposite of radio waves. They are emitted by radioactive material, given off during nuclear explosions and during certain types of thunderstorms. But despite their fearful reputation, they are also used to kill cancer cells, for medical and security scanning, and also by space observatories for astronomical observations. From ultraviolet to gamma rays, the energy associated is now higher. So these radiations are referred to as high energy radiations. These radiations are penetrative in nature and thus considered comparatively dangerous, where exposure to it is kept to a bare minimum. If these radiations have to be handled over longer periods, then appropriate precautions are taken. So far, we've discussed how all these types of radiations differ from one another. But as they're all part of one big family, they have something in common too. Despite differences in their wavelength, frequency, and energy, they all travel with the same speed, approximately 300 million meters per second, the fastest known speed in the universe. Now, as we conclude this session, let's have a quick recap of what we learned today. We learned that light, visible or otherwise, is a type of radiation called electromagnetic radiation. Electromagnetic radiations are of 7 types collectively belonging to a large family called the electromagnetic spectrum. What differentiates them are factors of wavelength, frequency, and energy. What unites them is their property of speed. But before we go away, here's a little something interesting. In both these images, we see the same light behaving differently with different matter. Do you know what these behaviors are? Okay, here's a hint. They both begin with the letter R. You can write your answers in the comment box below and tune into our subsequent videos to know more about them in detail. That's it for today. We hope you had fun in this session. Don't forget to subscribe, like, and comment. Until next time, keep watching, keep learning, and follow your curiosity. Thank you.